Port scanning is the process of checking for open ports, TCP or UDP ports on a remote machine. It is very important that you think of the traffic implications of your scans before you perform any, as it might have possible effects on the target machines. We have two methods for scanning a TCP port. The first method is called connect and the second method is called SYN/stealth. The first method is purely based on the three-way TCP handshake mechanism we saw earlier. The connect port scanning involves attempting to complete a three-way handshake with the target host on the specific port. If the handshake is totally completed, this indicates that the port is open. As for the SYN scan, it is a TCP port scanning method that involves only sending SYN packet to various ports on the target machine without completing the three-way TCP handshake. If the TCP port is open, a SYN ACK packet should be sent in return, and this means that the port is open without the need to send the final ACK packet to the target machine. It is called stealth because with the early and primitive firewalls, this method, like opening half a three-way handshake connection, often bypass the logging of the firewall. But this is not the case anymore with the new firewalls, as your scans will be detected. UDP scanning is different than TCP scanning, as we know that TCP is connection oriented while UDP is stateless. So it doesn't involve the three-way handshake mechanism. So scanning a UDP port is somehow different than scanning a TCP port. It is actually important to get into these details, as understanding these basics will help us a lot going through the course. So how does the UDP scanning work? Actually, an empty UDP packet is sent to the specific port, and if the UDP port is open, so we expect no reply will be sent back to us from the target machine. But if the UDP port is closed, an ICMP port unreachable packet should be sent back to us from the target machine. UDP port scanning is somehow unreliable, as firewalls and routers have the option to drop the ICMP packets. So this can be misleading to us. So people often forget to scan UDP services and stick only to scanning TCP ports. One of the most popular and robust port scanners to date is the famous Nmap tool. Believe me if I say that I saw complete penetration testing reports which are totally based only Nmap tool. So it's a great tool. It's very important to understand because this will help you a lot in your penetration testing career. It has numerous features, not only just port scanning, as you will see. The default Nmap TCP scan will scan like 1,000 most popular ports on a given machine. But again, consider the amount of traffic that you are generating. So this default 1,000 ports can generate up to 70 kilobytes of traffic. This is only scanning one port. So how about scanning like all the ports? This is only scanning 1,000 ports. So how about scanning all the ports? That's 65535 ports on the machine. It will actually generate around 4 megabytes of traffic. So 4 megabytes of traffic just for one host. How about scanning the full subnet? For example, the full subnet for a C-class network, which are like 254 hosts. It will generate lots of traffic that can compare to 1 gigabyte of traffic. So imagine if we scan a full Class B network. Imagine the size of traffic that we will be generating.